Sorry about that. This machine is not acting right for me today. So our next example, I have x cubed over the square root of 1 plus x squared. So we have the plus in there, so we're going to use tangent. So my u is going to equal x, and my a is going to equal 1. Again, I want to set up my right triangle. So since I have x equals 1 tangent theta, that means tangent is x over 1. And the hypotenuse is going to be the square root of 1 plus x squared. So again, I need to be able to substitute in for everything over here, so I'm going to start doing that. I know that x cubed I'm going to need, so that's going to be tangent cubed. X is 1 tangent theta. I want to know what dx is. So dx is derivative of tangent. It gives me secant squared theta d theta. And because I have a secant here, secant's in the derivative of tangent, I'm going to want to define this last piece in terms of secant. So we know secant's reciprocal of cosine. So 1 secant theta is going to equal the square root of 1 plus x squared. And I think I have everything I need. If I don't, I can always come back over here. But start plugging stuff in. X cubed is tangent cubed theta. Dx is secant squared theta d theta. And on the bottom, the square root of 1 plus x squared is 1 secant theta. Alright, so this secant will knock out one of those, and I end up with tangent squared theta, secant theta, d theta. I'm sorry, tangent cubed theta. I think I got ahead of myself. So I want to break that up to tangent squared theta times tangent theta, secant theta, d theta. And the reason that I want to do that is because now I can do a u substitution. So here I can make my u tangent theta, and du is going to be, I'm sorry, I'm still ahead of myself. I can't do it that way. I do want to break this up as to tangent squared, but derivative of tangent is secant squared, so that doesn't work. So let me try that again. Instead of tangent squared, I'm going to do my identity and make it secant squared theta minus 1. And then I have my tangent secant. I'm going to write in the other order so that I can identify it a little bit better. And now I'm going to make my u equal secant theta, and du is secant tangent. So this becomes u squared minus 1 du. Now I can integrate it. So this will be u cubed over 3 minus u. And then substitute it back into the trig, gives me secant cubed theta over 3 minus secant theta plus c, which I also can't leave it in because I originally started with algebraic, so I have to go back. So secant, we said, was the square root of 1 plus x squared. So that would give me 1 plus x squared to the 3 halves when you do secant cubed, because it was already in the square root. And then secant was 1 plus x squared, and then we have our plus c. All right. And then we have square root of 25 minus x squared over x dx. So my u is x, and my a is equal to 5. So I get x equals 5 sine theta, dx equals 5 cosine theta d theta. So here's my right triangle. And so since x is 5 sine theta, then we have x over 5, the sine's opposite over hypotenuse. And we're going to define cosine theta as square root of 25 minus x squared over 5. So just multiply the 5 and we get 5 cosine theta is the square root of 25 minus x squared. So I can start substituting in. Square root of 25 minus x squared, we just said, was 5 cosine theta. Dx is 5 cosine theta d theta. And then the x on the bottom is 5 sine theta. So those 5's cancel. I'll bring the other one out front. And we get 5 times cosine squared theta over sine theta d theta. So the easiest way for me to integrate this is put everything in terms of sines. Trying to think if there's a nicer way. I don't think so that I can think of right now. So I'm going to do 1 minus sine squared theta on top using the trig identity over sine theta d theta. And then we can break these up. So 1 over sine theta is cosecant theta. And then sine squared over sine, we get sine theta d theta. And now we can integrate. So the integral of cosecant is negative natural log of cosecant theta plus cotangent theta in absolute values. And the integral of negative sine is just cosine theta. And then we have to distribute that 5, but we can do that. I want to start back substituting. So we get negative 5 natural log cosecant. So over here, if we look at our triangle, cosecant is going to be 5 over x. And cotangent, again, we can pull it straight from the triangle, is 25 minus x squared over x. And then for cosine, we get 5, because I distributed that 5. And the cosine is square root of 25 minus x squared over 5. And those cancel. And plus c. So that is our final answer.